Good afternoon or morning or evening, wherever you are, everyone, and welcome to the final Open Ocean Fall 2020 seminar. I am Dr. Katie Croft-Bell, Director of the Open Ocean Initiative at the MIT Media Lab. In case you've missed previous events this year, you can find links to our 2020 seminars, and I just threw a whole bunch of links in the chat. So you can check those out. We have recordings, and we will also be recording Annie's seminar today to post if you'd like to see it again or share. So this fall, we're exploring access and equity in ocean science and recreation, and are considering how those critical components translate to deep sea exploration. Today, we will hear from Dr. Annie Brett, an assistant professor at the University of Florida's Levin School of Law. Her research focuses on how scientific data is used in environmental decision-making, including data collected using emerging methods and technologies. She's also an accomplished mariner. Fun fact, giving this seminar from a boat in Florida, recognized as the youngest female vessel captain to operate in the Pacific, and continues to participate in expeditions globally. Today, Annie will discuss the promise of new ocean data collection methods, the management of which currently remains siloed and parochial, undermining attempts to use new data to address global ocean issues. She'll also address the need for fundamental changes to ocean data infrastructure that are needed for the potential of new data technologies to advance ocean management. So this seminar will survey the ocean data landscape and identify potential paths forward. Please welcome Dr. Annie Brett.
Yay. Great. Thank you, Katie. It's great to see some familiar names and faces on the Zoom here. I'm just going to start by sharing some slides. But this seems like a relatively small group, so I'm happy if folks have questions as I go along to be interrupted if there's any pressing ocean data issues you want to discuss in further depth. So I'm going to start off by giving a little bit of what I think is the path or vision, let's say, for the future of ocean data, and then talk a little bit about where we are and how we begin to move forward to this future vision for ocean data. So I just want to start by showing this as a graph of data sets that have been added to the World Ocean Database, which is mostly a scientific database for those of you that aren't strictly in the ocean data and science world. But this is data sets that have been added to this database over the past century, essentially. And so you can see that in the past 10 to 20 years, we've collected more data than ever before. And we see this kind of rapid increase due to new and emerging methods of collecting data on the oceans, from kind of autonomous gliders to tags on marine mammals to other types of new technologies, often autonomous ones that are out in the ocean. So really, we're seeing this explosion in ocean data right now, which is a very exciting time for the ocean data space. But it also raises a lot of questions about what do we do with this data? And just having data in and of itself is not inherently going to give us any new insight or knowledge into the ocean or lead to better management outcomes in the end. So we're at this very exciting, but also very tricky point in the ocean data world. And I think a great time to really think about what the future of ocean data is and should look like, so that we don't get stuck in some of the mistakes that we have made for the past decades. So I'm going to start with just a little bit of a vision for ocean data. So we have this plethora of ocean data coming from many new sources, and the data in and of itself is not that useful. It becomes useful when we start to use it in science or management to really better understand ocean ecosystems and better manage those ecosystems. So I want to start just by thinking about marine protected areas, which are kind of one of the classic management tools that we're using right now to address marine management and to kind of better manage these resources. So we see a push on the international stage to have 30 by 30, so to protect huge swaths of our ocean resources. But these marine protected areas often are ineffective, are in many cases poorly policed and poorly regulated. And in many other places, we know very little about the scientific baselines of what's actually going on in these marine protected areas. So if this is our kind of most exciting, I won't say most exciting, if this is one of the kind of frontiers of marine management, is moving towards more protection of the ocean in marine protected areas, there is a huge possibility to turn what we currently have, which is a somewhat effective, but could be much more effective system, into one that is kind of exciting and at the cutting edge of using all the tools that we have from technology and data. And so some of these ways that we can reinvent the marine protected area system are thinking about dynamically managing these marine protected areas. So it seems that most of your ocean people on this, so I won't reiterate too much, but ocean ecosystems and many of the animals in them are dynamic. And so when you have static fixed marine protected areas, it inherently limits the effectiveness of those MPAs, right? So if you can instead create a marine protected area that tracks different types of species as they move across ocean basins, that becomes a much more effective management tool than if that marine protected area is stuck in one place as species move into and out of it. And so historically, this is something that we haven't really even been able to consider, because we haven't had the technology or the information that we need to be able to create these types of very dynamically moving marine protected areas or other types of dynamic management at all. But we're getting to a place where we now have the technological capacity and the management interest in beginning to rethink how our management systems really work. And so there's a lot of new tools that are kind of going into thinking about marine protected areas and other ocean management. This is an image of a wave glider, which is being used to collect data on ocean ecosystems, but there's also discussion of other autonomous vessels like this being used as enforcement for marine protected areas. There's new sources of data coming from citizen scientists, from fishers themselves reporting on marine protected area conditions through smartphones. This small image at the bottom here is of Boston, where there's been kind of dynamic protection of right whales for some time now. And so lots of interesting possibilities to rethink what has been a really solid effort to create marine protected areas around the world, but to rethink how we begin to incorporate new data streams to make these management methods much more effective. And so I think if we think about a future for ocean data, it's a future where we are collecting real-time data on ocean ecosystems, and that data is then directly being used to further management outcomes, either to support dynamic management or to have better enforcement of these types of areas. Lots of possibilities, but really the future of ocean data is a future where data is being well used in different types of decision making at the policy level. Obviously, as a law professor, I tend towards these policy outcomes, but I think in general, right, data in and of itself is not the end goal. And so I want to think a little bit about how we get from where we are to a future where all data is going into useful decision making. And I think regardless of what we think the future of ocean management is, and there's a lot of, be it dynamic management, like I was just talking about, or other types of management that we are thinking a lot about in the ocean policy world right now. There's a few kind of buzzwords that I think are coming up a lot. So dynamic management is one of them. Integrated management is another one of them, where we kind of are trying to move beyond the traditionally subject matter silos of ocean management, from just regulating fisheries and mining separately to thinking about integrated ocean management. So integrated ocean management, ecosystem-based management, rights-based management, where we're trying to have fisheries quotas that are more effective and property-based, to public-private partnerships, where we can really start to engage the private sector in some of these management outcomes. And then I think the last big thing we're thinking about in terms of the future of management is making our management systems much more global and accessible to a wide body of decision makers and stakeholders. But so regardless, really, I think of what you see as the future of ocean management, whether you think it's going to be dynamic MPAs or something that tends more towards global and accessibility, technology and better data systems are needed to enable these management innovations. And so these are really the foundation of a future of ocean management that is effective and is able to really deal with many of the emerging threats that we're seeing to the ocean ecosystems. So this is really the perspective from which I view ocean data, is as the support and as the tools that we need to innovate and to create new management outcomes for the ocean. So this is a bit of a convoluted table. I apologize for the text heavy slide, but this is something I can share. It's also part of, so all of this work was part of a longer thought process as a blue paper for the high level panel on the sustainable ocean economy. And so all of these images, or several of these images, including this table, are available in that paper as well. But the idea really here is that all of these types of emerging technologies and emerging data systems can enable us to manage our ocean resources better. But that is not where we are right now. And so there are lots of different ways in which the ways that we currently use, manage, store, access ocean data are preventing us from having the optimal outcomes that we would like to have. And so there's a few different kind of major barriers that are currently pretty entrenched in our ocean data system. Some of them, I think the most classic ones that we in the scientific community think about are the siloing of data. So either individual institutions, individual scientists, individual companies that are holding their own data very close and are unwilling to share it for a number of different reasons. As a scientist, you may be worried about someone else publishing before you using your data. You may be worried about your data quality not being up to snuff and someone finding out about that. You may be just hesitant to rethink the ways that you've historically shared scientific data and don't see a major upside to beginning to share data with anyone that is not you. Similar kind of concerns on the private industry side, where companies that are interested in resource extraction in particular are unwilling to share specific data they may have that has some commercial value to it. And likewise, governments, often publicly funded data is the best data we have, the best ocean data out there, and it tends to be the most well shared, but still is in systems that are often quite antiquated and difficult to access, and there's not the government interest or resources needed, if there is the interest, to make major changes to the ocean data landscape happen. And so what you have is a system where we have a lot of ocean data out there, but that ocean data is largely inaccessible. It's in different spots among different actors and very difficult to understand not only how to get access to data, but even that certain data sets exist. And so there's emerging methods that are beginning to overcome that particular barrier that I'll talk about in a minute, but it's a landscape that is very difficult in that way right now. And then we have data, a lot of data that even those that are willing to share their data with other people and other places in the ocean data landscape, that data may be of questionable quality, it may be very messy, and requires significant resources to go in and clean that data and make it something that can be added to an existing database. There's other types of data that are not digital that are super important, but also very difficult to integrate with the kind of traditional sources of digital data on ocean ecosystems, particularly the scientific ones. So the result is that a lot of the data out there on the oceans is not in the right place to be used in decision-making, either in scientific studies or by policymakers who are looking for management outcomes. And so obviously the ideal scenario is that we begin to move away from this system where we have a lot of siloed data, a lot of inaccessible data, a lot of unshared data, a lot of messy data, to one where we have a lot of good data and a lot of data that's shared in ways that make it accessible to a wide array of actors and that make it usable in decision-making. So this is just an example of this is a small example of a fisheries data system, just to kind of get into the weeds on what our current system looks like and what are some issues with it. Again, this is a bit of a complicated slide, so I apologize, but an interesting figure that I think lays out well what is currently happening in the fisheries space. In a lot of places, you have data that's coming in, it's either required by regulators, usually it's required by regulators. So data that's coming in and being collected by fishing vessel captains, often on paper sheets that are then mailed in to governance agencies. These paper sheets are supplemented by fixed GPS devices, so VMS devices, for those of you that are familiar with those. And so you have these two kind of major types of sources coming in. Again, one is paper. So there's someone usually in a government agency transcribing those paper notes. Often they're very difficult to read, which leads to huge errors in our data collection from a lot of these fishing vessels. And then this is all kind of put into a database that the management agency owns and runs, and no one else usually has access to that database with the exception of government scientists and other government entities. But importantly, fishers don't usually have access to this data. So may keep their own copies of their logs, but VMS records and other information like that is not something that fishers themselves generally have access to in this existing system. So a lot of different steps and a lot of ways. And then this data is just kind of held by the management agencies. And usually there's some interesting legal requirements that make sharing of this data quite difficult, or needs to be aggregated, or certain pieces of it can't be shared, which mean that the bulk of the data that's collected in this fishery system remains with the management agencies and leads to decision making, but on extremely long time horizons. So obviously in a better system, we move away from paper logs to start with, right? This should be relatively easy, but is in fact quite difficult. But even beyond just these simple things, it is really rethinking how this data flow works to make opportunities for it to be not just a one-way flow from fishermen to managers, but to make it a really kind of cyclical process where there's opportunities for different data users to have access to different data products throughout the system, and to have those data be available in relatively real time for decision making that's much, much faster and on the scale of the changes that are actually happening in ocean ecosystems. And so there's a few different this is actually an example. So this is a Nature Conservancy app that was developed, the eCatch data system. I mean, one of many emerging ways, I think, of rethinking this data system. But this is a way using smartphones that fishers themselves can collect, map, and share information about where, in particular, bycatch species are, to help others avoid high-risk areas and to decrease the amount of bycatch ultimately that's being caught. So in this type of scenario, right, you have someone, this is not necessarily a regulatory mandated data collection. This is something that the fishers themselves are doing and sharing the information as a net good for everyone, right, to reduce bycatch and to kind of help achieve regulatory outcomes. And this is very real time, so it's changing, so you're able to see the data over time. So this one example of one way that we can kind of start to rethink that system, but it's very difficult, very bureaucratic in a lot of ways, especially when we're thinking about data that's being collected to support specific laws and management outcomes. So if this is kind of the landscape of our current ocean data systems, a lot of different actors, a lot of siloed data, a lot of data that's not shared or accessible for many different folks, the question is, how do we move away from this system to one that really revolutionizes the way that we think about and use ocean data? I'm happy to talk more in questions about what the issues are with our current system, but I really want to focus on these looking forward and what changes we need to make to ocean data. And so I think there's three kind of major buckets that I wanted to think about today. One is rethinking what we think of as ocean data. And then one is how do we use, access, store ocean data? And the last is why. Why do we need to rethink ocean data? And how do we get others to realize that there's a kind of value add there? So I'm going to start with this. So I think one of the big pieces that we really need to expand on is what we think of as ocean data. And so a lot of the conversations that are happening now around revolutionizing ocean data and changing our ocean data systems are happening in the scientific community. And that's fantastic. I think a lot of the major progress that we're making in terms of standardization, in terms of data sharing, in terms of access for many different parties are coming from the scientific world. But this means that much of the conversations that are happening around ocean data really focus on this idea that ocean data is high quality scientific data, either oceanographic observations or meteorological observations, but relatively limited in what we understand as ocean data. And there's certainly conversations that are beginning to attempt to broaden the scope of what is ocean data, but I think this is a really essential piece of the puzzle going forward. Unfortunately, it adds a lot of complexity, right? It's a lot easier to create a data system that's just using oceanographic data. It's a lot harder when you try and draw in other types of data like traditional knowledge or citizen science or data from the private industry side, but it's really essential going forward that we understand that there are other types of data out there and really ask the hard questions about how we begin to integrate these effectively into our ocean data systems and our decision making. And so this is just a few examples. There's a bunch of other kind of options of how you frame and look at ocean data and what the different pieces of it are. Many of these types of data that are not scientific data, not quantitative scientific data, raise really difficult questions. The traditional knowledge questions like how do you begin to integrate data that's not quantitative, qualitative into data systems, and how do you weight that in different ways? Different types of data coming from different sources, like citizen science, raise questions about accuracy. So how do you potentially create a system that allows you to flag or note that certain data is collected using certain methods so that you can check if there's any quality or accuracy issues going forward? And this is actually, so in general, this idea of low quality data is one that I think about a lot from the legal perspective. I think there's a tendency, certainly in the scientific community, to throw all low quality data or data that has kind of concerns about accuracy out and not use it at all. And I think there's a huge potential to use low quality data in ways that recognize that it may not be to the highest standards of accuracy, but it can still tell us something, and tell us something often about ecosystems and areas where we have relatively little knowledge. So if we can figure out ways of incorporating low quality data in, for instance, first line decision-making about where to target future research as a kind of triage method, that gives us a lot of potential to expand the scope of how we use data and what we think about as data. So this is, I think, really the first piece of rethinking ocean data, is rethinking what we think of as ocean data. And I don't have all the answers to how we do this well, but it's a conversation that absolutely kind of needs to happen as we go forward and redesign our ocean data systems in the future. All right. And so then the second piece of this is the how. So how do we begin to redesign data systems to make storing, sharing, accessing data more accessible and easy for a wide variety of actors? And so this is, I think, actually one of the easiest questions to answer, simply because there are a lot of solutions out there and the technology exists, right? The technology exists that we need to build new data systems. What doesn't exist, and what I'll get to in the next point, is often the willpower or the financing or the time and expertise to actually make these things happen in practice. But the technological how, the technical details of these systems in many places do exist. And we're developing new ways to store and access data all the time. So just a few examples of what future data systems could look like. These are not exhaustive at all, but some of the ones that we've been thinking about in the course of our blue paper writing and some other data projects going on. So I think at the core of this, and any of you that are scientists will be, I'm sure, familiar with some of these efforts to standardize how we tag and associate metadata with different types of data sets. And the more that we standardize this globally, the easier it becomes to find new data sets and to be able to use data in different ways. And so there's some great efforts that are happening with this on the scientific side. Again, some global observing systems that have really done a great job. The ocean best practices here is just one example of this, but there's several others where a lot of thought is going into how we standardize and tag our data sets. And so I think there's opportunities to push beyond what the scientists are thinking about and really think about including a very broad landscape of data tagging and metadata in these standardization efforts that includes things like how data can be used. So similar to kind of the Creative Commons system that some of you may be familiar with, presumably if you've used the internet, the same kind of system can be used with ocean data, where a public institution that's funding research can tag data and note that this data should not be used for private sector profit going forward, or that this data should only be used for research purposes, or any similar kind of ideas that think about how we license and use data and beginning to standardize that, as well as kind of the more nitty-gritty scientific metadata that we've thought about. So there's a huge amount of power there to begin to standardize data in a lot of different ways, and some good efforts that are being made. But these are really, this is the supporting structure of any kind of data architecture going forward, is these standardization efforts. So there's two, I think that this specific, the idea of standardizing metadata and standardizing data tagging, support two architectures that we've thought a lot about. And one is Federated Networks, which has been prominently used in healthcare and has begun to be used actually in various places in the ocean world as well. But this is essentially the idea that no matter how much we change the culture of data, there will always be some actors that are hesitant to share their ocean data, be it private sector that don't want to be commercially compromised because of it, or if it's perhaps defense departments that are collecting huge volumes of oceanographic data but don't want to disclose certain pieces of it. There are ways to essentially allow those data holders to maintain ownership and control over their data, and then have a federated server that allows you to send queries into their data and get answers as needed without releasing the kind of raw data itself from those entities. So you have networks, these federated networks, where no one can see the entirety of private data, but you have ways of accessing it and using it in the decision-making process. And so this has been, again, super common, becoming more common in the healthcare field, where there's huge privacy concerns. And so you can't share confidential information about anything personal and anyone's personal health records, right? But there are ways that you want to be able to query across a wide spread of people to get accurate information. And so these, you can have brokers and trusted brokers and federated networks that are able to create these and come up with the answers without violating privacy. And so this presents some interesting opportunities, mostly for, I think, areas of the ocean data space where there are private sector concerns or governmental concerns about commercial or kind of national security interests. The second piece that we think is pretty interesting opportunity is around data lakes, which are an interesting option. There's a lot of debate about this on the kind of more tech company side of the world, less on the ocean side of the world. But data lakes are a new, usually cloud-based method of storing a wide array of unstructured data, and they allow this unstructured data to be, you can run analytics on this and then generate different insights pretty easily on the cloud. And it, these data lakes can essentially be nodes in larger federated networks. And so data lakes, I think in particular, present interesting options for the scientific community, where there are fewer concerns about privacy or some of the concerns that we may see on the private sector end of the spectrum. And so just for a quick example of data lakes, and also a quick example of how quickly things can happen. So not to talk about COVID again, which I know we are all sick of talking about or hearing about, but in the months following COVID, we've seen a huge amount of government interest and also private sector collaboration on sharing data around COVID. And obviously this is usually super confidential data where you have to overcome significant privacy barriers. And so data lakes and federated networks both have been really important pieces of the COVID recovery. This is the Amazon Web Services created a COVID-19 data lake that's been super important in generating insights across the globe about COVID cases and recovery. And so presents interesting options and also shows how quickly these types of solutions can be ramped up if there's the willpower and the interest. So those are, I think, a few different examples of architectures that can help to overcome some of the existing concerns about sharing ocean data more broadly. There's a bunch more out there and there's a lot of different ideas. And I think my main point maybe in thinking about how we restructure ocean data is that there's a lot of different ways that it can be done, and we have the technical ability to do it. And so the last big question that I think we need to answer is really, why are we doing this, and how do we get others to realize that we need to change the way that ocean data is structured? And this is really the critical question at this point. How do we generate the political buy-in? How do we generate that at both the highest governmental levels as well as the kind of individual scientist level? How do we make people move from their current system of storing data to a new one that maybe requires them to rethink their workflows and is a giant pain for them to redo? How do we kind of overcome these barriers and get people to buy into creating a more open data architecture that really empowers ocean decision-making on a broader level? So there's a couple interesting things that are happening here. This is a map of the high-level panel for the sustainable ocean economy, which is 14 governments that just committed to 100% sustainably managing their oceans by 2030, but have developed a couple interesting data projects as part of that. And if you think that you could have high-level buy-in from a bunch of governments to begin sharing their data using standardized methods, that type of commitment could be a tipping point, right? If you have enough governments buy into this and you have the beginning of a wave, as it were, of ocean data sharing. Beyond that, again, apologies for the text-heavy slide. This is one of our recommendations from the blue paper I mentioned earlier, and there's a bunch more, but I wanted to actually go through these ones in a little bit more depth because I think there's a lot of important next steps that can happen here to kind of move people's defaults, as it were, from what has been a pretty messy siloed system to one where we can have much more open, usable data in the future. And so I think our main message overall was that we really need to change the default. And the default should be that all ocean data is open, essentially, and broadly available, unless there's some compelling reason for it not to be. And so what that compelling reason is can be kind of up to the users, but that they're really, we need to change the norm here from what it is to a culture where sharing ocean data is expected. And there's a bunch of different ways to do this. There's some interesting governmental initiatives. The UK, for instance, any research that's funded by the UK Marine Council, I forgot their name anyway, the UK Marine government arm has to be made publicly available within 2 years after it's collected. That kind of time buffer gives scientists enough time to use and publish their data before anyone else, and then it has to be shared publicly. So interesting efforts like that are being made. The US is thinking about similar kind of avenues, as are several other countries, but really important to get government buy-in because that kind of regulatory push can be really important in beginning to change these norms. Likewise, as scientists, I think even when there isn't a push from regulators, it's increasingly important that scientists commit to sharing data broadly, but also to including the resources in their projects for supporting data architecture and data sharing and making sure that there is sufficient time and manpower devoted to this piece of the puzzle, because what we're seeing now is very, very large grants are happening, often without enough money devoted to the data management side of things, and things end up getting very messy. And so there's some interesting new numbers that people are throwing around about how much of grants should be devoted to the data side. And I know 10% is an interesting number I think that a lot of people have landed on, but could easily be higher, could be lower, but let's say 10%. Is a good target to aim for, and it's increasingly important that we recognize that that's a really critical piece of a lot of these ocean science projects going forward. And then I think the last piece that we really wanted to push on is the idea that industry needs to make the environmental data they collect available. And there's different ways that we can do that while still retaining some commercial rights, but that can have a lot of power also in beginning to push accountability. And we see this in a lot of the movements towards seafood traceability and transparency, as well as other types of transparency throughout the commercial ecosystem. And so I think there's a beginning to understand from the company perspective that this type of transparency can actually be really powerful. But all of these are kind of, I think, changing the cultural norms around data takes a lot of time and requires a lot of commitment and rethinking from actors throughout the sector. So I think I'm actually just going to stop there for now. It seems like there's a lot of questions and stuff in the chat, and I'd love to get into more of this going forward. And I encourage you all, I don't have a link here, but the blue paper for the high-level panel for a sustainable ocean economy gets into many more of these recommendations in depth around how we begin to rethink ocean data. But I will stop there. Thank you all, and I look forward to answering your questions.